At the beginning, our way of traveling started on foot, bicycle, boats, motorcycle, ship, and then eventually air travel was invented. This made it possible for people to travel long distance in a short amount of time. And as it grew popular, numerous flight stations were created. Now, given this station, a modified shortest path algorithm is used in order to find the optimal route to keep the travel distance short and also cost-friendly to the passengers. Welcome to our video presentation explaining airline networks using shortest path algorithm. Before we start, let's talk about minor concept views. Vertices are the points or nodes in a graph, representing entities like cities in a map or character in a network. Edges are the connection between vertices, showing relationship or paths between them, such as roads between cities or relationship between people. In a weighted graph, each edge has a value or weight associated with it, indicating factors like distance, cost, or importance between connected vertices. How do airlines deal with this problem? Well, they are using a system that solves the shortest path. Let's use this weighted graph as an example. Philippines, Korea, Japan, Singapore, Taiwan, where the countries will serve as the vertices. The path leading to each country will be the edges, and their weight as their costs. Now, for the system to find the shortest path, it will begin by using the Dijkstra algorithm. Dijkstra's algorithm tells you the shortest path from starting node to the ending node in the weighted graph. Starting from a node point A to point B, we will simply test each unvisited neighbor node and compare which is the shortest path from one node to another. The system requires the shortest path for every vertex. With the same concept of Dijkstra algorithm, there exists another one called all pairs shortest path algorithm. Unlike Dijkstra, all pairs collect all the shortest path between all vertices.
An algorithm of the system, which we'll name as Algorithm 1, will then occur that will enhance Dijkstra algorithm by utilizing Priority Queue and Fenwick tree. Priority Queue manages tasks. In the context of the airline system, think of the tasks as vertices or points in the flight network, and the priority as the distance from the source, like the starting point for a flight. The priority queue helps in exploring the closest vertices first, which helps in finding the shortest path quicker. Fenwick tree is a clever data structure that helps in efficiently finding the minimum value among a set of numbers. In the context of an airline system, you can think of the distances between vertices or points in the flight network as these numbers. The Fenwick tree helps in quickly finding the shortest distance encountered so far for each vertex, which is helpful in finding the shortest path efficiently. Algorithm 1 will then initialize a priority queue to organize vertices based on their minimum distances from the source and create a Fenwick tree to manage minimum prefix values. Prefix values are those short distances that are already known by the system. Another algorithm, which we will name Algorithm 2, will then occur that will create a new graph based on the data that will be provided by the first algorithm. At this point, the system is already unusable and users are now able to enter an arriving and departure point. Algorithm 3 will then be utilized to search the feasible paths between entered points. The system will provide the shortest path between the 2 points and provide a path connecting vertices as valid landing airport points up to the departure point. With these algorithms, experts are able to find optimized reachable paths for every airport in an airline network. A modified version of the shortest path algorithm utilized to find the best route that's both short for travel distance and doesn't cost passengers too much. We hope that you have learned the work behind airline networks. Thank you so much for watching and always keep on learning.